Well, greetings, mathletes, and welcome back. Today we're going to carry on with our constructions, but we're going to insert a couple of other things. We're going to talk about congruency statements in and of themselves. When you actually say two things are congruent, there's a lot of implications that come along with that statement, and so we're going to talk about those. Um, we're going to talk about the two congruencies we constructed last time, side, 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 and side, angle, side constructions. But we're going to talk about them in terms of congruency now and how to recognize congruency using those criteria. Um, and then from there, we're going to do some constructions of some triangle centers. We have three. One of them is more just for demonstration. It's not going to be a whole lot of use for us right now. But the ones that will be useful to us are the end circle and the circumcircle. And those will be constructions that we do today too. So in any case, without further ado, let's go ahead and start this up. All right. So let's go ahead and start with our congruent statements. Let's see here. Maybe I can zoom in on this just a hair. Too much. Maybe right there. Okay. And then we need to decide on a font size. Okay. So let's say, yeah, that seems adequately big. Triangle ABC is congruent to triangle DEF. Okay, so if these two triangles are congruent, the positions of each of these letters that indicate the vertices of the triangle, right, the corners of the triangle, each one of these letters represents that point. Well, their position tells you how they correspond. So just from the, oops, I forgot to make it congruent. There we go. Now it's congruent. Um, the position of these letters tells you something. So first of all, because A and D, they both occupy position 1 in each of these statements, that means that angle A is congruent to angle D. And because B and E correspond, angle B has to be congruent to angle E, right? And you can say the same thing about angle C and angle F, right? Those guys they correspond. This is what we talk about when we're talking about corresponding parts of congruent figures. Right now we're talking about congruent triangles, but these are corresponding parts of these two congruent figures. Now, the other thing is that this tells you about the sides also, which sides of the triangle, of which side of triangle ABC corresponds to which sides of triangle DEF. Now, ABC has three sides. Now, you notice I haven't drawn a picture yet. I'm doing that deliberately. We'll draw a picture here in a second. But AB are the first two letters, and that means that there is a side that connects A and B. So we have side AB, and D and E occupy those same first two positions. So AB is congruent to DE. And then we can also look at BC and EF, right? BC has to be congruent, oops, yeah, there we go, to EF, right? And it's because BC are together and EF are together. So you can actually read all these corresponding parts. Now, the last one's probably a little tricky to get a hold of, but A and C have a side connecting them. So AC has to be congruent to DF. And so we use the positions of the vertices to tell us all of these pieces of information at the same time. Now we can see that here. Well, let me draw. Ay, ay, ay. That's it. We're going to have to use technology. There we go. And then let's say I have this other triangle here. Okay, so let's say this is A, B, C. Okay, and then this is D, E, F. And we want to figure out from these two statements which sides correspond to each other, right? So first of all, I'm going to start with the angles because that's usually the nicest way to go. We saw that from these first two statements. A and D are congruent to each other. So that means that this angle is congruent to this angle. You notice how I'm doing this independent of the position. I'm just looking at the letters. B corresponds to E. So angle B and angle E have the same measure. And then C and F also have the same measure. So those angles correspond to each other. Now, we want the sides. Well, let's see. AB and DE have the same measure. We can see that from this. So that means AB and DE are the same size. We can move to the next thing. BC and EF also have to correspond. So BC and EF are the same size. And you notice that only leaves one side. I have the side AC, and that was the one that was a little tougher to see because the first and the last positions actually connect themselves. So A connects to C, and D connects to F. And so that's our last side. And those are congruent. And so you need to be able to read those statements out of this statement because this little statement of congruence means everything I just drew. Right? All of those statements come out of this little guy right here. So you need to be able to reconstruct all those things. And in reverse, if you know two triangles are congruent, you need to be able to write this congruent statement so that these letters correspond. They have the same position if the angles are congruent. So you have to match the order of these things up as well. Okay, so that's that part. We'll go ahead and switch to the next page here. Okay, so let's work the process backwards now. Because once we show two things are congruent, we also need to be able to write them in a way that conveys all of their congruences, right? So it's the correct congruent statement because there's actually quite a few congruent statements for triangles. So let's see what we have here. So first of all, we have to decide whether this is enough information for us to be congruent. So you can see side AB, right? That's congruent to side DF, right? And then side AC is congruent to side DE, right? And then we have an angle. Angle A is congruent to angle D. Okay, so notice we have two sides and an angle. So we have two congruence criteria that we've worked on so far. We have seen side, 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 and that can't be the case this time because we don't have three sides that we know are congruent yet. And then we have side, angle, side. Now, keep in mind with side, angle, side, the way this has to be organized, they have to be in this configuration. You have to have a side, another side, and these are the two that you know, and then you know the angle between them, right? The angle that the two sides make with each other. So that's what side, angle, side looks like. And it wouldn't be the case if I had this angle instead, because then I have two sides and then an angle instead of a side, an angle, then another side. So this is why it's called side, angle, side. And we can see that we do have that situation here. As a matter of fact, let me highlight it in red here. Kind of. Right? Here's that situation right here. And I'm making the same angle here with the same side lengths. And so that is enough information to say that these two things are congruent by side, angle, side. Now, the other things that you get for free, well, actually, let's go ahead and make the statement first. So let's just go ahead and start with triangle ABC. And we need to figure out what the correspondences are so that we can write these angles in the correct order. Okay, so first we need to see what A corresponds to, right? So let's look. A is the same as D, so that means D has to come first. Now, you don't necessarily write these things in alphabetical order. Just because D, E, F is the natural way to write things, not necessarily what you want to do. Okay, so what we do is we look at our sides next. Okay, so side AB, right, corresponds to side DF. They're congruent. So this side, so when we go from A to B, it's the same thing as going from D to F, right? It says so right here. So F is the next letter. And that it's actually supposed to be an F. That wasn't a miswritten E this time. Okay, now we have to be able to do the same thing. I mean, process of elimination tells you the next thing is E, right? But we can see that down here too. So if A goes to C, that's the same thing as D going to E, right? So that means that this side is the same as this side, right? So the last letter is E. And now we can get all the other congruencies out of this one statement once we've established that they're actually congruent, right? Okay, good. Let's go ahead and take a look at the next one. Okay, so we've seen the straightforward case. What we're looking at now is a case where we have to do a little bit of digging to find some of the information we need. So I just want to look at these two problems. I want to make sure we understand them, and then these are problems I want you to see if you can work them out. Okay, they take a little bit of thinking when you work them out. So give yourself 5, maybe 10 minutes to sit there and push it around. Don't expect to see the answer right away. As a matter of fact, your homework is kind of the same ways, where you have to spend some time thinking because, well, there's too much to explain every little detail. You have to be able to fill in the details yourself. Okay, so here's what we have. We have a kite, right? So we're told this is a kite. With the kite, let's see here. We have AD is congruent to AB. Okay, so those two are congruent. What's not stated is that DC is also congruent to CB. These two sides are also congruent. I didn't mention it because it's actually not needed, but the other statement is that AC bisects DAB. So let's see, DAB, and here's AC. So what does that mean to bisect an angle? Well, it means exactly what you think it means. You're cutting it into two equal angles. So saying that this bisects this angle is telling me right away that this angle is congruent to this angle, that those two angles are congruent. Okay, so that's the information you have for the first one. Here for the second one. So we're told this is a parallelogram. So that means the opposite sides are parallel. That's actually the only information you get when you're told something is a parallelogram. Okay, everything else happens to be a consequence. But so that means, yeah, so we got our parallel statement, and this symbol right here, the two parallel lines next to each other vertically, that's a symbol for, for parallelism. Okay, so we have the two sets of parallel lines, and then we're given one congruent statement. AB is congruent to DC. So maybe I'll make that mark in a different color. So this is congruent to this, right? So we can mark that down there. Okay, so what we want to do here is, let's see, ABD. So that's this triangle right here. We're trying to figure out which congruence we have, which triangle in this picture is congruent. So these are two separate problems. Give yourself a decent amount of time to work on these. If it's not obvious to you, that's okay. It doesn't necessarily have to be. Okay, at least not right away. So go ahead and pause it here and see if you can work this out and figure out the triangle congruencies here. So let's go ahead and pause. You've paused it, right? Do I have to get up there and check? Okay, so let's go ahead and take a look. So here's, in fact, I'm going to do this in a different color so we can see what stuff I've added to this. So let's see here. We have one side and we have an angle. And we know these sides are there. So I have two sides and an angle, but the angle's not between the sides. So here's the thing that most people miss. The last congruency that you need to figure out what is congruent to this, because I think most of you can see triangle ACD is probably congruent to triangle ACB, right? But we need another side. We need the other side. And you notice this side right here is the same side. They share a side, right? The triangles share a side. That means that side is congruent to itself. So when something's congruent to itself, we actually just kind of put a little S on it. So we can say that side AC is congruent to side AC, and that's a side of both triangles. And so that gives us side, angle, side in both cases. Okay, so triangle ACD, let's see here. Let's see if we can match these statements up. So A goes to D, A goes to B. So that means, let's see, that would be triangle. Let's see, we're going to start with A still because A corresponds to itself. Let's see here, that goes to D. Let's see if we can find something a little bit better here. AC is congruent to AC. So that means there's a C right here. Notice they have the same position. And then B is the last side. So A goes to D over here. A goes to B over here. We can see that in this statement as well, right? So the last piece is going to be B. It's the idea of self-similarity, or excuse me, that self-congruence that throws people off because it's so obvious that something is congruent to itself that most people just overlook that statement and look for something else to make it congruent to. But no, it's congruent to itself. It happens to be a part of both triangles. Now, over here, we get the same thing, right? BD is congruent to BD. So we can add that in here. BD is congruent to BD. That's something we discovered just now. Okay, so now let's see what we have. So we have AB is congruent to DC. Okay, so we can kind of see some of these correspondences here. Now what we need to find here is an angle, right? This is where the parallelism comes in. Okay, because things are parallel, we have alternate interior angles all over the place. So let's look at what we have. I have a side, I have a side, and then the same thing over here. I have a side and a side. So this side corresponds to this side, and this side corresponds to itself. What we need to do is get this angle congruent to this angle, right? And you notice because AB is parallel, right? AB is parallel to DC. These are opposite interior angles, right? So that means that angle ABD is congruent to angle, oh wait, try that again, CDB. There we go, CDB. Yeah, I started with D for some weird reason. Yeah, so we have this congruency also. And now you notice what we have is we have side, angle, side. So this side is congruent to itself. These are the angles between the two sides that are congruent, right? So again, by side, angle, side. If we could show that this side was congruent to this side, we could also prove it by side, side, side. right? So you want to be thinking about all the different things you can do to show these are congruent. So now let's see. Triangle, that's supposed to be a triangle. Triangle ABD, we know it's side, side, side. Triangle ABD, let's see if we can get the correspondence here. So A is going to correspond to C, right? They're on, those are the angles that work, that go together. So we'll throw a C here. Let's see here. B has the same angle measure as D. So AB, so that means the next thing is D. And then let's see here. Oh, and it's just going to be the other angle here. So again, we're going to swap B and D. So D goes, or yeah, so B goes to D and D goes to B. Right? And so that's our congruent statement. And that gives us all the other congruencies we need. I do want to point out that certain times, for example, what we did up here, when we showed that these two triangles were congruent, we actually were showing that the other side was congruent, right? Over here, by showing that these two triangles are congruent, we just showed that the opposite, the sides, the non-apex sides of the kite are congruent angles, right? So we just got properties of other shapes by using properties of triangles. I think that's pretty cool, actually. It's kind of a fascinating thing that it's just this wonderful indirect way of getting information. You kind of feel like a bit of a ninja being able to sneak this information out of stuff. Okay, so we've looked at a few examples of that. So let's go ahead and take a look at the last thing. Okay, so this last part, we're going to take a look at some specific constructions, okay? And actually the constructions we're going to look at are circle centers. And so, or not circle centers, triangle centers. And there's more than one type of center for a triangle. So let's go ahead and take a look here. So the in-center is a triangle center. It happens to be a center of the in-circle. Now the in-circle is a circle that you can draw inside the triangle that you have in front of you. So the sides of the circle are tangent to all the sides of the triangle, right? Or all the sides of the triangle are tangent to the circle, I should say. So the idea then is that what you want to end up finding is a point somewhere in here so that the distance to the sides is all the same, right? Because that would be the radius. Well, the way we end up doing that is actually by using angle bisectors. So the intersection of angle bisectors I have to watch myself. My habit is to write small, so believe it or not, I'm writing big right now. Okay, so we need to figure out where all the angle bisectors meet. So that means we have to construct angle bisectors. So we're going to get out our compass, and this works with pretty much any circle or any triangle. As a matter of fact, if you have 3 points, right, you can still, well, I guess 3 points wouldn't matter so much with this, but there are constructions that all you actually need are 3 points. So let's go ahead and start with this. So go ahead and make our arc because we need to bisect this circle, right? So what that means is that, or God, I keep saying the wrong word. I'm going to actually stretch this out a little more for this one, just so we can get a good crosshatch here. And so remember, the construction, you start by making an arc. What that does is it makes sure that the length from here to here is the same as the length from here to here, right? Then these are from these points, you open up the compass so it's as big as you want, really. You just don't move it between points, and you make a cross hatch from each of these points. This point right here is what we're going to draw our line through to bisect the angle. Okay, so let's see here. fact, let's do that in a different color just so it's clear what I'm given and what I was constructed. Okay, so there's our first angle bisector. So I can say that that is congruent to that. So now we need to do that with each of the other angles. Okay, so let's go ahead and we'll close this up a little bit. Sometimes it's just being strategic about not having your lines go over each other. All right, and then we'll open it up big. I like to have the hatches, the farther away the hatches are from the angle you're bisecting, the more accurate the bisection is. So I like to open this up a little bit. So I don't want to get involved with that angle, so we'll do that, and then from this side we'll do the same. Make sure we're good. Yep. Okay, so now I have my crossing here, and that's going to go to this angle. And so we'll go ahead and connect that. Right, so we have those two. And since those two cross here, as long as we've been doing things correctly so far, the last angle bisector should go through the same point. What we say is that the angle bisectors are concurrent at a point, and that point is the incenter. Okay, so let's do the last angle here. So once again, we'll close this guy up. All right, make sure we have good distances. Yeah, we got there. We'll mark from here to here. Okay, so we got that mark in there, and now we need to open this back up. Oop, I'm turning it the wrong way. All right, make it big enough to have some distant crossings. Let's make it a little bigger. Okay. Main thing I'm trying to do is make sure that these hatches I don't get them confused with each other. So I'm trying to make sure they're spaced out a little bit. Okay, so that should be the last one. And this will be our test to see if we've done it correctly. I'm nervous. I actually am, because I don't want to have to re-record this section. But let's find out. So if I like, oh, look at that beautiful thing. Boom. Wow, I think that's about the best construction I've done of this. Wow. Okay, so this point right here, that's our incenter, right? So we've bisected all our angles. Right, all of the angles are bisected, and they meet here in the incenter. Now, we have to see if this is an incenter. So, now I'm actually going to do this by eye, which is the wrong way to do it. Really what you should do is construct a perpendicular that goes through this point and one of the sides, and then see what that intersection is. But if we close this compass up, and if we do this correctly, let's do it so you can see it. Right, so I want to get this so that we match up with the side. Okay. Okay, so it looks like it's tangent to one side, which means it should be tangent to all sides, if I've done this correctly. And here we go. There we are. I jumped the compass again. Doggone it. There we go. Well, it's not perfect, but you do get the idea. That circle should sit inside the triangle perfectly without exiting the triangle and without being too small to stay inside the triangle. You can kind of tell my compass strokes wasn't that great. I'll try to make the next triangle bigger so that that'll actually make it work a lot better. Okay, so intersection of angle bisectors will be the incenter every single time, right? the in-center will always be on the interior of the triangle. The other two centers we're going to look at, actually, they don't need to be on the interior of the triangle. And they'll have bigger circles involved, so I won't have that problem of trying to squeeze everything inside here. I'm just curious. Let me try this one more time. Oh, my compass jumped. That's what happened. Yeah, because it's working perfect now. Okay, that was a good one. Okay, anyways, that's me diverging. Um, let's go ahead and take a look at the next one. The next one we're going to look at is called the circumcenter. And basically what it is, it's also a similar center, but what we'll be able to do is draw a circle from that center that touches each of the vertices, right? So that what that means is that it's equally spaced from all the vertices. Okay, so let's take a look at the next one. So the circumcenter and circumcircle. Okay, so the circumcenter and the circumcircle are they're both triangle centers, or excuse me, the circumcenter is a triangle center. Sometimes it is interior to the triangle, sometimes it is exterior to the triangle, and it actually works like this. If there's an angle in this triangle, if one of the angles is over 90 degrees, then the circumcenter is on the outside of the triangle. If they are all acute angles, then the circumcenter is on the inside of the triangle. And since we have no obtuse angles in this, at least not that I can tell, I'm pretty sure all of these are less than 90 degrees. What that means is that in this case, the circumcenter is going to be on the inside of the triangle. So let's go ahead and take a look. We find this, the circumcenter and circumcircle, by looking at the intersection of perpendicular bisectors. Right? Now, we've seen perpendicular bisectors. That was in the last lecture, how to do a perpendicular bisection of a side. Well, this is no different. We're just going to do it to all three sides. So let's go ahead and figure that out. So we want to open this up. We're just going to pick a side. And I'm going to open this up so that it's bigger than half the size of the thing. And I'm just going to make a light arc. And then I'm going to come back here and I'm going to do the same thing. And then when I connect these, and I'll do these in red as well, right? I'm going to connect the two intersections here and here. Let's get those right on there. That cuts the side in half into two equal pieces, and that line is perpendicular to the line. So I have a right angle here, and this side is congruent to this side. Okay, so we're going to do the same thing to another side now. So let's just pick something. Oops, wrong way. So close this up a little. That's one. And that's two. So we just need to connect this point, oops, wrong pen, this point with this point, right? Don't get confused and think it's this point. So we need to join these two guys here. Oops, let's do it this way, that'll be easier. So I'm just being careful about this. One thing about compass and straight edge constructions is that it is important to take some care in what you're doing, because otherwise a little bit of sloppiness about an arc or anything like that, and you're just going to get a bad measurement. So, okay, so we have two of them that cross here. If we've done this correctly, the last one will cross here too. So we still need to bisect this side. So let's go ahead and do that. Let's see how we're doing here. More than half. And you know what? I need a different sized arc. You can actually combine some of these. There we go. I'm just going to make it bigger. Ooh, too big. Yeah, whatever. we'll just do it this way. And now the other side is here. Okay. So from here to here should be my perpendicular bisector, as long as I've done this right. Well, that's pretty close. We're in here somewhere. That's too bad. Looks like one of my lines wasn't quite right. It's pretty close. Usually this is what happens to me. It's just very slightly off. There's a tiny triangle here. Now, here's the idea though. If we've done this right, I should be able to measure the distance from this center to one of the vertices. Oops, we're sliding around here again. Oh, too small. Here. Okay, so it goes through there. It should also go through this one and go through this one. And so there you go. If I go ahead and make the circle, this outer circle here, this guy, touches each one of these triangle corners exactly once, right? And this is the center of the circle that does that. That's what the circumcenter is. The circumcircle is the actual circle once you draw that, right? So that's kind of fun. So we've seen what happens when we have angle bisectors that intersect. We've seen what happens when we have side perpendicular bisectors that intersect. Now there's another measurement on a triangle, and it's called an altitude. Okay, so we actually need another construction to be able to construct altitudes. So we're going to take a look at that here. There we go. So what we need to be able to do is find a perpendicular line through a point. Right, so if I have, let's put it this way. No, let's put it this way. Okay, so if I have a line and a point, right, and I want my perpendicular line to go right through this point. Well, I know how to bisect a line, but that always puts it at the midpoint. This point, I can move this point over here. I can move it over here. I should be able to put it anywhere and then put my perpendicular where I want it. So here's how it works. We need the compass. Okay, so what we're going to do is create a line segment so that the perpendicular, whatever it happens to be, is the midpoint. And then when we draw our perpendicular bisector, it'll go through here. So if I take, oops, wrong way. If I take a compass and I just mark a couple of points on here, right? Now I have a line segment. I have a segment from here to here, right? So I can look at that segment. If I bisect this segment, since this distance is the same as this distance, right? Those two distances are the same. If I bisect this, it's going to go straight up here because what I've done is I have an isosceles triangle here, is what I just forced to happen. So all I need to do now is bisect what I have. So let's go back the other way. So we'll go ahead and do this again, and then we'll do it from the other point, and those points should line up pretty well. They look like they do. And so we have now a perpendicular or not a bisector. We have a perpendicular through a particular point. Okay, now here's how this is going to play out. When you have to construct an altitude of a triangle, so let's just make sure we understand what an altitude is. Well, let's do it this way. It's a small drawing, but it'll be okay. We'll get a bigger drawing here in a minute. Okay, so what an altitude is, it's, right, here's a point, and here's a line. It is the perpendicular from this side through the opposite vertex. So this is an altitude, right? Now, you notice there's a problem with these other two sides here. Sometimes this happens. Like if I want to draw a perpendicular to its opposite side that's over here, there's no line here. So what we do is we just extend the line, right? So what's in black is still your original triangle. But the altitude then would be here, right? And you notice they're not intersecting. But if I go ahead and just extend these lines, because an altitude actually goes as far as you want it to, right? There's another one. And then we have, let's see here, we have to figure out the altitude for this side. So I'll, and then we need a perpendicular here. So these are actually a little tougher to see and to construct. Actually, that would be probably something like that, right? And they should intersect. But the altitude is just the perpendicular that connects the opposite side and its vertex, right? That's what an altitude is. They always form right angles with the side that they're constructed from. And they go through the opposite vertex. Okay, and it turns out that they are concurrent. They meet at a point called the orthocenter. So let's take a look at the orthocenter. See how that plays out. So this one too, just like the circumcenter, sometimes it's on the exterior of the triangle, sometimes it's on the interior of the triangle. It's basically the same rules. If this angle here, right, whatever whatever your bigger angle is, if it is obtuse, it's on the outside. If it's acute, it's on the inside. And then actually, if it's a right angle, the center actually ends up being right on the corner, right on the vertex itself. Try that again. Okay, so let's see if we can construct an orthocenter. I want to save time and just draw the triangle first. Okay, so we have our triangle here. We need to construct our altitudes so we can see if we can get them to be concurrent. Okay, so that means that I need to find a perpendicular to this side that goes through this point. I need to find a perpendicular to this side that goes through this point, and I need a perpendicular to this side that goes through this point, right? And I made this triangle just a little bit obtuse so we can see how we have to handle things when the center is on the outside. If it's on the inside, you don't have to extend any of the sides like this. But it turns out that when it's on the outside, you have a problem because the perpendicular distance from this side is on the exterior of the triangle, right? So let's go ahead and take a look. So first I'm going to find the perpendicular from this side to here. So we get our handy dandy compass out, and we'll go ahead and open this bad boy up. Just big enough to get a couple of swatches in here, right? Notice I just made my two intersections. We'll go ahead and mark that here and here. You know, and honestly, the way this actually works, the compass construction is only as good as the sharpness of your pencil. Let's make that bigger. So we'll go here and here, and then we'll jump to here and do here and here. Okay, so we'll do this one in red so we can see what we got here. I kind of wish I could change the color of my compass stroke so you can see the difference between what I'm doing with the compass and the triangle itself, but I think this is what we got to work with here. Okay, so there's our, well, it didn't really go quite through the, well, we'll say it's there. We'll just make the corner bigger. That's what we'll do. There you go. The bigger the point, the easier it is to hit. Okay, so now we need to do this with our other sides. Now, part of the problem we have, and I'm going to extend these sides in blue. um, is that we need to have enough of a side to actually mark. So sometimes you have to go out of your way to extend a side so you can play with it. So let's go ahead and do that here. So we need to mark off two equidistant pieces. Maybe I could turn this way. Yeah, that's a little better view. Okay, so we want, let's do here and here. Okay, so now I have my 2 points here and here. And I want to make my perpendicular bisector now. So we will make an arc here and here. And then we'll jump to the other point, do the same. All right. And so that line, when I connect this guys up, oop, kind of went over the edge there, but so I have a point here where things have crossed, right? So the next goal, let's see, which one do we have to do now? We have to do this side, right? So I'm going to have to extend this side and put something through here. If I'm lucky, it's going to go right through there. But I do suspect I'm a little bit off, but we'll see. Let's go ahead and extend this just a hair. Let's see, we got the line on there. Okay, so now what we need is the perpendicular from this point to this guy. Ugh, I'm running out of room real fast. You can see how these things get messy really quickly. Okay, so now all we need to do is actually make that perpendicular. And I'm going to stretch this out a bit so that the hatch marks don't. There we go. Let's see what happens. I'm nervous. I am actually. We'll see what happens. Okay, because I'm not sure if this is. Oh, it's pretty close. Oh, there we go. That's why. Well, it's not quite concurrent the way I did it, but that's again subject to just my um, the error in my construction. But that is the idea behind this whole thing. So these do take some patience, right? It's kind of like putting together a clock, right? If you don't get all the pieces just right, it's just not going to work. So you do have to have things very careful. So please be patient with yourself as you work on these. Um, you might have to use a little creativity for some of your homework problems because I can't cover every possible situation, and your homework really does draw things from a lot of different directions. So, in any case, keep in touch with me with any issues, and I will talk to you guys in the next lecture. So until then, keep your pencils and your wits sharp.